Alright, so here is the circuit from the most recent quiz, and we're going to solve for everything. So the goal here is to solve for V1, V1, V2, V3, V4, then we also need to solve for our currents, I1, I2, I3, and I4. And in this one, we are missing a resistor as well, so R4. The first quiz I gave you, we were dealing with knowing all of the resistors, but we didn't have the current, or we didn't have the voltage or something, and now in this one, we are missing a resistor instead. So all of that's fine. We can just break this down piece by piece and work on just a little bit at a time. The first thing that we're going to want to do is look at our circuit here for this this part where we are in parallel and try to reduce that into an equivalent resistor. So we can just use the law for equivalent resistance in parallel, which is just that 1 over RT is equal to 1 over R1 plus 1 over R2. So in this case, we're going to call our total resistance for this little section R12 because it's the total resistance of R1 and R2. So we will say that 1 over R12 is equal to 1 over R1 plus, whoops, don't want my plus sign to go down there, plus 1 over R2. So 1 over R12 is equal to 1 over R1 plus 1 over R2. And we have these numbers, they're simply given in the problems. R1 is 15 and R2 is 30 ohms. So we can just fill in our numbers there. So this would just be equal to 1 over 15 ohms plus 1 over 30 ohms. And we can add these two fractions together quite simply by just finding a common denominator, and our common denominator could be many options, but our simplest one is just going to be to make it 30. So if we make our first one into 30, multiplying both by 2, so top and bottom by 2, 2 over 30 ohms plus 1 over 30 ohms. Add 1 and 2 together, you get 3. So we end up with 3 over 30 ohms. And remember, this is equal to 1 over R12. It's not R12, it's 1 over R12, which is a rather important distinction to be making. Because now, if we want to find R12, we just need to flip both fractions and do some simplifying. So to simplify 3 over 30 is just 1 over 10. So let's write that in. Which equals 1 over 10 ohms. Which means that R12, flipping both fractions, is equal to just 10 ohms. So now what we've done is we have made an equivalent resistor. So we can take this, paste it, put it over here. And effectively what we've done is we've reduced these two resistors here into just one resistor with a resistance of 10 ohms. So let's draw that in. And then we can label that. So R12, which is equal to 10 ohms. So we've now simplified our circuit, and this is going to make it easier for us to find the total voltage drops, because it's often easier to find the total voltage drops when we're in series. It just simplifies everything. Now, we know that the total voltage in, which is by the battery, needs to be taken out by all of the resistors. So that tells us this, that IS equal to, or sorry, that Vs is equal to V12 plus, and then our next resistor is over here, so that's our next voltage drop, V3 plus, and then our last one is V4. Now this is really where we want to end up getting to, but we don't have all of our voltage drops yet. So what we're going to need to do is calculate each of those. And then what we will find is that we will end up being able to solve for R4 by the end of it. So we have our currents, because we can use Kirchhoff's current law to tell us that whatever current comes in is the current that comes out. So in this case, our current of the source is just 0.5. That's pretty simple. We have 0.5. And also, let's put a box around this just so that we can find it later. So our current in is 0.5, and because this is in series, that means that our current here in R12 is 0.5, our current through R3 is 0.5, and our current through R4 is also 0.5. So we should be able to find our voltage for R12 and our voltage for R3, which is going to become handy in just a second. Now, the thing that we cannot find is our voltage for R4, but then we can use this here to solve for that. So we're not going to get too worried about that. We're just going to take this one piece at a time. So let's solve for our first voltage, which will be V12. It'll be the voltage that we lose through the combined resistor 1, 2. So we can use V equals IR, so V12 equals I12 R12. We're trying to solve for the voltage, so we don't need to do any reorganization. We have I12, and we have R12 in this big red box over here, so we can just fill that in. I12 is 0.5 amps. R12 is 10 ohms. And half of 10 is simply 5. So 5 volts. That's what we end up losing in this first resistor here. Next up, we should find V3. V3 is going to be equal to I3 times R3. So V3 is equal to I3 R3, which is equal to, remember our currents are all the same. And actually, let's write that in above our circuit. Let's do it in a different color, just because it's a pretty important concept. So IS is equal to I12, which is equal to I3, which is equal to I4. This is true at every point in this circuit, right? Because we are in series, so we can't have different currents because what goes in must come out, and there's only one path to be taken here. There's only one path to be taken, then our currents cannot change. Okay, so coming back to our voltage 3 calculation, let's fill in our newly written I3, if we'd actually written that, equal to 0.5, of course, which is equal to 0.5 amps. There we go. Okay, so 0.5 times R3. Our R3 is 18 ohms. 18 ohms. 0.5 times 18 is just half of 18, which is going to give us 9, and we are measuring a voltage, so we measure it in the units of volts. All right, so now let's look at what we have found. We have now found our V12 is equal to 5 volts. Now V12 isn't one of the things that we're initially looking for. We need V1 and V2, but we're going to get to that later. V3 we have now found is equal to 9 volts. And V3 is actually one of the things that we were searching for. So we can stroke that off. We were also looking for I3 and I4, which we have also found up here. So we can cross those ones off because they have been found. And now we can use this relationship down here in order to solve for our V4. We have the total voltage of the system, which is just the battery, right? 15. And whatever comes in needs to be dropped by these resistors. So we are losing 5 here, and we are losing 9 here, so we're going to need to lose a little bit more here to get us to 15. Now, that's going to end up being 1, but let's solve it just for completeness. All right, so coming back down to this equation down here, we have Vs equals V1 plus V3 plus V4, and we are looking for V4, so a simple rearrangement is just Vs minus V12 minus V3 is equal to V4. Plugging in all of our numbers, Vs is 15. That's just told to us by the battery. 15 volts minus V12. We calculated up there is 5 volts. 5 volts minus V3 is 9 volts. Minus 9 volts is equal to 15 minus 5 is 10 minus 9 gives us 1 volt. So this is equal to V4, which equals V4. And again, let's put a nice little red box around that so we can find it later. 1 volt is equal to V4. So V4 has now been found. We can cross that off of our list of things to be found. So what's up next? We need V1, V2, I1, I2, and R4. R4 is probably going to be our easiest thing to find. R4 can simply be found with V equals IR, and we just found V, and our I is the same through everything, 0.5. So let's solve for that. So I'll just come under here and go V4 equals I4 R4. We are looking for R4, so we'll just divide both sides by I4. V4 over I4 is equal to R4. All right, plug in some numbers. V4 right there, 1 volt. And I4 up here, 0.5 amps. So that's just 1 volt divided by 0.5 amps is equal to R4. And this is just double 1, which is just 2. So 2, and we're measuring resistance, so it should be ohms, is equal to R4. So there's our R4. R4 can now be crossed off of our list of things to find. We now have to deal with I1, I2, V1, and V2. Now in order to do those, we're going to need to look at our circuit back over here. Because here we've collapsed those resistors into one, but if we're trying to solve for them separately, we need to come back to our initial circuit drawing where we have the resistors separate. So we know that V1 is going to be equal to I1R1, and we know that V2 is going to be equal to I2R2, but we don't know what our currents are going to be because our currents end up getting split here. We have this junction, we have one path in, but 2 paths out. So our current is going to be unequally split here. So we need to have some sort of relationship in order to figure out what's going on here. And the relationship that we have is that our voltage drops need to be exactly the same regardless of which path we take. Quite simply, that's because all of the electrons that follow this path through R1 need to lose that 15 volts. And any of our electrons that follow our path through this path up here, through R2, need to also lose that 15 volts. Now, it's losing 9 over here and 1 down here. So either way, it needs to lose 5 volts. So the voltage of R12 is exactly the same as the voltage of R1, which is exactly the same as the voltage of R2. Or I should say V12 is equal to V1 is equal to V2. So let's write that down. And I'll write that down over here next to, or just below my first circuit. So V1, 2 is equal to V1, which is equal to V2, which is equal to 5 volts. Well, that actually immediately crosses off two of our things up here, V1 and V2. Easy enough. Now we need to be concerned about I1 and I2. So again, we'll put this in a box in case we need it later for some of our checks. But I1 and I2 are the last things that we need to solve for. So let's just start with I1. So I1, again, Ohm's law, V1 equals I1 R1. Well, what do we have here? Do we have everything that we need? We're looking for I1. Do we have R1? Well, yes, it's given in the question. And we have V1. Yeah, we just figured that out via Kirchhoff's voltage law. Here it is 5 volts. So we'll just solve for I by dividing both sides by R1. So V1 over R1 is equal to I1. And then our numbers here, we'll just fill in. That's 5 volts divided by, it is for R1, 15 ohms. Which means that we get I1 is equal to 5 over 15, which is 1 over 3, and we measure this in amps. So there's our first current there, I1. And again, we can put this in a nice orange box so that it is easier to find later. I1, we can cross that off of our list up here. And now we want to solve for I2. Now you could change this into a decimal if you really want to, but there's nothing wrong with keeping it as a fraction. I'm not going to penalize you in any way for keeping it as a fraction. It's more exact, and really the numbers will work out slightly nicer if you just keep it as a fraction. So I would advise doing that. Now for for I2, V2 equals I2 R2. Do we have all of our numbers that we need here? We're looking for I, so we're going to need R and V. R is given in the question, and V, from Kirchhoff's voltage law up here, we have is equal to 5. So solving for I by dividing both sides by R2, we have V2 over R2 is equal to I2. Plugging in our numbers is just 5, so 5 volts, divided by our resistance, which is 30, measured in ohms, equals I2, which tells us that I2 is, if we simplify this fraction, we just get 1 over 6. 1 over 6, and this is a current, which is measured in amps. So that's the last thing that we needed to find. We can cross it off our list, we can put a big box around it. And there we go. That's everything that we need. And everything's been put in nice boxes here. So we could do a couple of checks. So here's one check that we could do. We could check and make sure that the current coming into this parallel section is the same as the current coming out. So we should get that IS is equal to I1 plus I2. So let's check that real quick. And I'm going to check it way over here. So just scroll over here. So here I have my check. I should have that IS is equal to I1 plus I2. So what is my I1 and what's my I2? Well, my I1 is 1 over 3. So let's do a left side, right side check, right? We're not entirely sure if this is actually true yet. So I'll throw a question mark beside it. Let's do left side, right side. So left side is equal to just our IS. IS is 0.5. 0.5 amps. And our right side is equal to, well, it's a little bit more complicated, but not much. We have I1 is 1 over 3. So that is 1 over 3 amps plus, and then I2 is 1 over 6. 1 over 6 amps. Finding a common denominator is 6. 2 over 6 plus 1 over 6, which is equal to 3 over 6, which is 0.5. So that is one check because our left side is equal to our right side, which is exactly what we want. So let's write that in. Left side equals right side. So there's one check that we can make. What is another check that we can make? We could check and make sure that our resistance down here is correct. So we could do V equals IR for R4. We could check that. Why not? Just check it again. V4 equals I4 R4. This should work out because this is exactly how we calculated it the first time. So V4 is 1 volt, so left side equals 1 volt. Right side is equal to I4, we found was 0.5 amps. And R4 is, we found that somewhere. R4, it's down here, I didn't put it in a box. 2 times 2 ohms. 2 ohms. A half times 2 is just equal to 1. And that is volts. So that means that our right side is equal to our left side. So that's another good check that we could make. What else could we do? We could check our total voltages again. So we could check the voltage across the entire system. So let's come up here and check the voltage across the entire system. So Vs is equal to, now we could check across either path, right? We could check through this V1 path, or we could check through this V2 path. So let's check through V1. V1 plus V3 plus V4. So left side is equal to Vs, which is just 15 volts. Right side, this is going to be equal to V1, which is 5, plus V3, so there's V1. V3 was over here, 9 volts. 9 volts plus our V4, which is over here, 1 volt. Plus 1 volt, which is equal to 5 plus 9 plus 1 is equal to 15 volts. So we have left side is equal to 15, right side is equal to 15. So we have left side equals right side, and that is what we want. So that is also good. And we can check whatever else you want. You could do V equals IR for any one of these resistors. You could do it for R4, R3. You could do it for R12. You could do it for R1 individually and R2 individually. You could check however you want. Just do a left side, right side check for any of those. V equals IR. All of your currents should be the same through the series. Your currents should add up through the parallel, which is what we checked over here. So any of those are good checks to make. I would definitely advise checking your currents through your parallel series and checking your voltage across the entire system to make sure that those work out. Those are probably your two major checks to make. Anyway, that's everything that we need to solve for. So practice up over the weekend, and good luck on your circuit solving.